All right, we're going to have some theorems on chords and arcs now for section 12.2. So, here we go. Theorem 12.4 and its converse. So within a circle or incongruent circles, congruent central angles have congruent arcs. So the converse of that, if they're congruent arcs, then they have congruent central angles. So basically, this is something we already know. If these angles are congruent, then the arcs are congruent, okay? All right, so we marked that, and then we've got some information here, which is basically what we marked. Angle AOB and COD is what we marked right here. So then we marked the arcs AB and CD, and then vice versa, okay? So let's try this example down here, which says if angle AOB is congruent to angle XOY, so I'm given that these are congruent, then I would know that arc AB is congruent to arc XY, so AB congruent to XY. So the next one, within a circle or congruent circles, congruent central angles also have congruent chords, and the converse of that, so just the opposite order. So, here we go. So if the angles, angle AOB and COD are congruent, then I can say that this little chord right here, AB, has got to be congruent to CD, and vice versa. If the chords were congruent, I could say the central angles were congruent. So in this example, again, I'm given that AOB is congruent to XOY, those angles. So then I can say that these chords are congruent. So now it's AB as a segment and XY as a segment that are congruent, that are chords of this circle. All right, now we have congruent chords, have congruent arcs. So we have covered all the bases, central angles, chords, and arcs now. So now I've got AB, the chords, so AB and CD, the chords are congruent. Then I would know that these arcs were congruent, okay? And vice versa, you could have the arcs first and then know the chords. So in this case, what it should have given you is these as chords. So those are the segments. So if I know that AB is congruent to XY, then I know this arc AB is congruent to this arc XY. All right? So basically, if they're all measuring the same parts of the circle, central angles, arcs, and chords, they're all going to be the same. So let's try this example. In the diagram, circle O and circle P are congruent. So given that BC is congruent to DF, so BC is congruent to DF, and we're talking about the chords because of those hats that it has. Remember, you have to just know that. So now we're going to say what we could conclude. So if I know the chords are congruent, I know the angles are congruent. So I can say angle BOC is congruent to angle DPF. And it also means that these arcs are congruent. So I could say BC, the arc, is congruent to DF, the arc. All right? So the chords, the central angles, and the arcs are all congruent then. All right, 12.7. Within a circle or incongruent circle, chords equidistant from the center or centers are congruent. So basically, there we go. So OE, if OE was congruent to OF, which is marked here and here, then AB, this length here, is congruent to CD here. So those chords are going to be congruent, or vice versa. Okay, so let's look at this example. What we have marked is that we have these chords right here, AB and XY are equidistant from the center, and we know that because of those markings. So then I can say that AB is equal or congruent, that should be a congruent symbol, to XY. All right, so let's work on this example. What is the length of RS in circle O? So I know these are both marked as 9. So those are actually congruent, which means these chords right here are equidistant from the center, so they should also be congruent. So if I find out what PR is, that's going to be the same as SR. So PR, this part's 12.5, so this has to be 12.5, which makes the whole thing 25, which makes SR also 25, or RS, as they called it. Okay? So number 2 on that same part says, what is the value of X? Justify your answer. All right, so I was given now that this chord is 36. This chord here is actually also 36 because 18 and 18 makes 36. So if the chords are congruent, then I know they are actually equidistant from the center. So X is 16. There wasn't any solving here, it's just knowing these theorems. All right, flipping over to the back side. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc, okay? So we can see this picture here. It says that AB is a diameter. So then, and AB was perpendicular, so we had this marking here. Then we could say that CE and ED were congruent, and that those arcs, CA and AD, were congruent. So let's look at this picture. I have that AB is a diameter right here, and I know because it goes through the center, and I also have that it is perpendicular. So I can make these markings that those sections are congruent, so it split it in half, and I also have that the arc got split in half. So we need a letter right here. Let's put letter C there so we can actually name these things. So let's call this chord XC is now congruent to chord CY, so it got bisected. And then the arc, this arc right here actually got bisected, so now XB is congruent to BY. And these should also be congruency symbols, not equal signs, okay? So now this right here is actually just the converse of that other theorem. So now if a diameter bisects a chord, then it is perpendicular. So now I have that AB right here was a diameter, and I know that it bisected this chord, then I can say that AB is perpendicular to CD. So we were just given different information first, but the information is all the same. So right here, I was given that this chord and this chord are equal, which means that AB bisected it. So what I can put into this picture is that that is perpendicular. Okay, so I could say that AB is perpendicular to XY. And remember, that's our symbol for perpendicular. All right, the last thing, 1210. In a circle, the perpendicular bisector of a chord contains the center of the circle. So this is still, all 3 of these theorems on this page all go together. You're just given a little bit of different information. So now it says that AB is the perpendicular bisector. So I know it met at a right angle and it was bisected. Then you know, there we go, that AB contains the center of circle O, which basically all that says right here is that AB is a diameter. Okay? So it means that if AB went through the center, then it has to be a diameter. And that was the information we were given previously, is it had to be a diameter in these kinds of problems. So if we look at this example down here, we have that it was bisected and the right angle. So then I know somewhere on AB has to be the center. So then I can conclude that AB is a diameter, or that it goes through the center. Okay, but most of the time you'll conclude that it's a diameter because a lot of times that will give you a length for a problem you are solving. So let's just do some examples. What is the value of each variable to the nearest tenths place? All right, so right here, I've got that this line right here is perpendicular, and that would be a diameter since it came from the center. Okay, so I can say that it got bisected right here. And if I know the whole thing was 14, then I know that is 7, and that is 7. And how that helps me to find r right here is that now I have a right triangle. That's where they go a lot with these problems. So r actually has to be my hypotenuse. So I would have 7 squared plus 3 squared equals r squared. And then solving, you get that r is equal to 7.6 when rounded to the tenths place. All right, so setting up that Pythagorean theorem. We use it a lot with circles. Let's try example B as the last one. So now I'm finding angle, or not angle, this line that's represented by y right here. All right, so again, I see that this got bisected. So what we can put into the picture is that this should be a right angle. So now again, I have a right triangle, but I have two sides that are missing right now. I have y that I need to find. I know this one's 11, but I don't know what this one is. But actually you do, because it is a radius, since it goes from the center to the outside. Well, this one was also a radius, so this side is 15. So 15 is our hypotenuse, since it's across from our right angle. So we have 11 squared plus y squared equals 15 squared. And when you use your Pythagorean theorem to solve for y, oops, we don't want y squared. Remember, we want y, so don't forget to square root. We get 10.2 as our answer. All right, bring these notes filled into class.